Hello, I'm Hello Jasper and welcome to a KTANE module tutorial for mislocation.
All available experts, please report to room
On this
A9.
module there are 4 tubes in a square, which each refer to their respective direction. The center tube is the submit button, and the tube in the bottom left relocates you to a random position to counteract soft locks, where you get stuck. The maze is a random shape with 19 square tiles, of which all but one are linked in pairs. Moving on to a tile will teleport you to the tile it's paired with. And so, for example, if you have a tile here, and you move here, you don't actually end up here, but instead you get teleported to this tile. To solve the module, you need to figure out how the tiles interconnect, and then locate the tile that does not teleport you, and that tile will be the solution. So, when the tube is lit, when one of these 4 tubes is lit, that is a wall. So, this tile here has a wall, and we can go these 3 directions, and we denote pairs with letters to to denote the pairs. So when you solve a mislocation, it's useful to find a line of consecutive uh, places where if you find that light again, you know that you
Emergency
went
clear.
from
All
somewhere to
personnel,
get into the
please
line.
return to your stations.
So you can connect the pieces together because 2 different spaces went to the same location. Or, yeah, from 2 different locations you went to the same space. So, I generally always move right, so that's what I will be doing. So, it just so happens to be the same kind of tile, so move right again. Now it's completely empty. Move right again. Another completely empty one. At first it's just finding new tiles and giving them numbers. And eventually you'll find you go back to tiles you've already been in, and then you can continue to go different directions. So for example, if we find we went back to B somewhere, to Bravo, then we can, for example, check what happens when you go down from Bravo to find out what these positions are. But right now it's just, this module takes a while. There's a, I'll skip I to because of confusion between I and India and Lima. Here we have Juliet, Kilo, you might have a loop here with this and this. So went to the left here, or went to the right here to get into it. Are we in here? Looks like we are. So this will take us here, this will take us here. Yeah, just checking. Yes, this is indeed the loop. So this is the same as this. So this H here is the same as the C. So this capital H, which is paired with this, is the same as this capital C. So we can change this to a C. Remove this, because that's just useless duplication. And then we can merge these together like this, because they both went to C. So now we go a different direction, like down from F here. To see where that brings us. That's a new tile. Because we haven't gotten one that's on the left yet. Moving to the right. Continuing. This might again be a loop. Might be that, but nope, it wasn't. Oh no, wait, never mind. It definitely can be a loop. So if you go left now, it's empty, empty. Yeah, this is this one. Yeah, because so we got on here from this K. So this K is equal to that F. So this K is equal to that F. So this is a capital F, which we can connect like this. We're there. Let's go to G. Now let's go down from here. Kilo. Empty. Now, we get here again. So we might have gone to delta. It's entirely possible. But just to be sure, let's continue for a little bit up from that. Yes. So then G. Yeah, and then K is back here, but oh yeah. So this K is the same as this delta. So this K is the same as this delta. So this is a delta. So we can connect this in here. And then again we can remove these because they're duplicates. So let's go to H and let's go down. Essentially you continue doing it like this until you have completed the entire maze. So you've went to all of the empty spaces that you have not gone to. Did I click down already? Well, now I did. I might have messed that up. I'll check later. This is loop again. Is this loop again? M1 to E. L. Is this L? Oh, I went there from K. Let's check a bit more. Yeah, that looks correct. Okay, so this is E, this is D, so this is D. This is a new position because we don't have that one yet. So this is D. Remove duplicates and connect them. Over here, go to H. Okay, yeah, okay. So this is immediately K. There's not one in between. Back to D, to E, to F, to H. Now go up. So I want to know what's there. It's an empty one. Let's continue. Okay. It's a corner we did not have before. Let's continue. Another empty one. Continue going through the maze. Let's start a second row. That's okay. I might be here now. So we might have found our capital A, which we didn't have yet. Oh. So just, yeah, it's just going through this one by one. Empty space, another empty space. Yeah, we were here. So if this is that, that would be that. So the seal made us here, which is empty. And the right was this, which is another empty. So I just confirmed that's indeed the option. So this is alpha. So this is capital alpha, but you didn't have yet. This is again duplicates. So let's go to, doesn't matter, it's G, then go left to C. So we can check down, I guess, make this map bigger, because it seems to be increasing in size the best. So I just continue doing this until the maze is done. So this is again this. So you are at. So this is E. This is capital E. Which we didn't have the right side of that yet, so that's new. So yeah, a lot of new ones. Oh. Slowly but surely it's getting more and more completed. Now let's take the left of C. Okay, this is empty again. I think there are only 19 squares, so you should only get to the 19th letter in the alphabet, which is S. So if you go past that, that essentially means that you already have duplicates somewhere. So this combination here makes me think that we are the FG combination here. Just going to the left gave us the empty space. So yeah, I'm fairly certain we're there. So this is F. So this is the J. So this is J. Capital J. So that means we have this to connect there. which definitely filled a lot more from what we had. That was capital R, so this can be removed. So we have up till Q. Yeah, we have up till Q. So that's 17 unique positions. So there are only 2 positions that we have never been on. There's only 1 left in this bit. To connect to the rest, we'll have to find the others that connect on the other side. We're at C. How do we get to K? Kilo. There. Hotel Foxtrot. Okay, so that's going right to Delta, going right to Echo, and up to Foxtrot. Down to Hotel, and then down to Kilo. And then let's test out what there is. What's there? Okay, another empty one. Oops. Is that? What's that? Is that this? Not sure. Or it might be. Ah, yeah. It's. Oh. Might be new. Not sure. Let's look at it more. So. TU. That wall. V. Yeah, this is echo. So, this U was Q. So this T was P. This T is P, so this was O. This is capital O, but we didn't have this position yet. So this is capital O, and then this here is new. So we do indeed have a new position. I was confused where the arrow was, but it was here. So we have a new position in maze. Let's go there now. F. So that means we have to go back to Hotel, Kilo, Romeo, and then check what down is. That is only one spot we haven't had before, so we'll generally very quickly run into a loop now. So where is this? Is this G? So this is F, capital F. Oh, we don't actually have this. If it is capital F, let's check. So that's that direction, so we're on C, go to D, go to Echo. Yeah, that's indeed the same position. So this is Foxtrot. So we have Sierra now as well. So that's every single square we're going to have. Anything else we'll find. It will just be previous squares that we've been to connect them. Foxtrot, let's. I guess we can go up from here. Foxtrot. So it's back to Hotel, Kilo, Romeo, and then Sierra. And then check up. empty spaces. I like to do this in Excel, but you can do it in whatever, as long as you can connect them easily and note down every direction. So I assume this is going to be, yeah. When I found this wall, we only have one piece, so that's Q. And then going left was echo indeed, so this is Q. So this is P, this is O, this is O, so this is R. So there's capital T again, there, so this is capital R. And that just means we can do like this over there. Nice, so we're getting most of the maze in. This is 9 squares, 14, this is... So if this square gets filled in, it will be the entire grid. So it's probably either one of these two that ends up going there. Or not. That will go there. Never mind. Let's check. This might also just not be in the grids because it's a random shape. Echo, right? Yes, it's now here. Foxtrot, let's go to something that's not in the grid. Let's go to Golf, let's go to Delta, because Delta is very empty right now. So let's check the left of Delta. The left of Delta was this. Oh. Huh. So that brought us back to E. So this is Q. Just this is echo, so this is Q. Where's the other Q that we had? There. So we can grab this and put it here. You might wonder why, if this maze is almost complete, we have so many separate pieces still. But I'll explain that when we have the full maze. Foxtrot, Golf, Delta. Now let's go down. Okay, that's another empty space again. Oh. Where is this? Can I get a better reference point, please? Is this Alpha Bravo? It looks like Alpha Bravo. Charlie, and Delta as well, yeah. Oh, I'm not Delta. Nice. So this is Alpha, so this is capital Alpha, this is November. November. So we can connect this up over there. Let's get this closer. So that's November. Okay. I'm in Delta. Okay, nice. Let's go up again. Tango. What's this loop? Is this Alpha Bravo again? Is it? Charlie is empty, Delta's empty, and then Echo. So yeah, this is Alpha. This is Alpha. So this is there. We're getting there. Oh, random error. Foxtrot. Golf. Oh, wait, that's not golf. Yeah, wait, it is golf. Let's go for Charlie. I guess let's go here. Let's go to Oscar. Oscar. What's to the left? This. The Alpha Bravo. So this is Alpha. This is Alpha. So we're on the other side now. Let's check up from Oscar again. Go to Charlie, Oscar, go up. It is important that you at least sort of remember where you are whenever you fill in this. Another empty one. Is this? Yeah, this is Echo. This is Delta, which comes from Charlie. Charlie comes from Bravo. This is Bravo. So we finally can connect this here. I guess let's go to Alpha. Echo. No, yeah, Echo, Foxtrot. What's the quickest way to go to Alpha? Oscar. Right. So go to Golf. And then go to Charlie. And then down to Oscar. And Oscar, then go left to Alpha. Now we want to note over there. So, Tango. Uniform. Which series is this again? Oh, that's Echo. Okay. Sure. This is Delta. This is then Charlie. This is Charlie. So this is Golf. Ah. Golf. So we can put this in there. And it seems like we're almost done. Just have this to connect. Foxtrot. I have to get to Lima. Bravo Orta. Oh, we're Foxtrot Hotel and then up to Lima. We're over there. And I guess we're going left to an empty space. Uniform, which is just up. Victor. This is Alpha Bravo. This is Alpha. Alpha capital. So November. This is November. Which is what I expected. Just one more position to check. What's this? Which one is it? Wait, which one is it? Oh, we also this. Huh. Oh right, we skipped India, of course. This is Bravo, right? Charlie, being Delta, Echo, yeah. Foxtrot, what was it? Oh, right, Hotel. Then up to Lima. And then go here to Tango. So actually, it's the very last space we go to, but we've actually never been here. Which is interesting. This is very obviously going to be that space. Yeah, of course. Romeo. Wait, no. Assuming things here. I mean, yeah. It's fairly safe to assume that at this point, but it's nothing unique. It's not unique. X-ray. Okay, that's unique. That's Quebec. So this is Quebec. This is then Papa. This is Oscar. This is Romeo. So this is indeed Romeo, which is what I expected. So this just goes in there. Interesting that we had not found that space. So now the question, now what you've probably noticed is we have two identically shaped mazes. But that's because this maze is, as you can notice, it's checkerboard with capital letters and lowercase letters. And this maze is the opposite checkerboard with capital and lowercase letters. And that's because if you go from a lowercase to an uppercase, then you don't know the walls of that uppercase. It just immediately teleports you somewhere else, wherever that might be. Now, if you end up stepping onto the lowercase that's connected to that from one of the adjacent ones, so here, from one of these, you'll step here. You will not see the walls here, so you will not know that was a four-way. You'll just get teleported here and see there's a wall above it. And then from here, again, you can move, but you can't tell those walls. So, because there's no way to tell what's on a capital letter, but you do get teleported to it and get on it. It's just, you don't know that it's that letter. So we have two mazes here. Both are, it's essentially the same maze. So for example, with this Lima pair, which is also this same Foxtrot pair. Now the point is to figure out which square does not teleport you. So it will be the only square that doesn't have like Tango Echo, such a pair. It's the one that has on both ones the same square on both mazes will have the uppercase and lowercase of itself, which is, if I quickly scan over it, is hotel in this case. So this hotel is this hotel. So, which means that if you were to step on this hotel from here, you'll be put here, which is the same spot. So hotel will be our answer. We're on Quebec right now, so we're going to Echo, and up to Foxtrot, here, and then down to hotel, and put it here. So now we can submit, and that's a solved problem. Now, you don't necessarily need to make the full mazes like I did this time, as long as you have enough of a shape. So like if I had this upper half here with maybe like this line here, so like this shape, and then here I had like this shape. That might still be a bit ambiguous. This is not the easiest shape to do that with. But if you had a like a very weird stretchy shape and you had another very weird stretchy shape, then you won't have to make the entire maze, because you can see, oh, this part here obviously is the same maze part as this part here, and then you can already see, oh, so are any of those letters already the same? And if you find the letter that is the same in that, then you can already submit it. You don't have to go through the rest of the maze figuring it out. There was a time that I had like just a random upper half of the maze and another random lower half of the maze, and the same letter just happened to be in the middle line. So when I had both upper half and lower half, I already saw, well, they can't be further up compared to each other, because then there's not enough room to have all of the letters in the area. And if it was lower, there will be too much open space that we did not have. So the only option was for that square to already be the solution. Which is also a way how you can go about it. So I guess that was it. Mostly. One thing to mention. We got these two can essentially make an infinite loop. I did not have a case where it was really irritating, because I went right and the loop is top to bottom, so I didn't really have to use it. But if you find such a loop going right, then if you keep going right, you'll just be in an infinite loop, and well, not all squares you find in that direction are all different. So what you would assume in that case is that there is such a loop, but you don't know how long that loop is. Because for example, this A here could go to this B, and then this B here could go, just assume this is also an A, so this could go back here. So it might be 2 squares, but it might also just be 1 square like this. And it might also be 3 squares. There's no way to tell, as every square looks identical and also acts identical, aside from when you move in a different direction. But then you're outside of the loop, so you can check the rest. So the best suggestion in that case is to move in that loop exactly 12 times. Because if you move exactly 12 times, then if it's just a 1-1 loop, you'll obviously stay at the same space. If it's 2 loop, well, it's even, so you will end up at the same space. And even if it's a 3 or 4 loop, you will still end up at the same space, because 12 is divisible by all of those. And, well, with the amount of squares we have, a 5 loop almost never happens. So, that way you can say, okay, I went from here to here, moved through it 12 times, so I'm very much sure that this indeed connects to here. So I can connect those together. And then, if I find a way to get here again consistently, then I can find, okay, if this first one going down, where does that go? And then check, okay, if I go on here, and then go only once to the next space, and then go down, does that also bring me to that same spot? If yes, then it's only then both the first and second of the loop went to the same place, so the loop is just a 1-1 loop. If they went to different places, it might be a 2 loop. In which case you have to check if the third one also goes to a different place, because then might even be a 3 loop. And that's essentially the only thing you need to remember. The rest is the rest you can figure out from the rest was gone through in this tutorial. So that was it. Bye bye.